Okay, this is the first question of the second problem set. We have the usual linear equation and we have the usual full rank assumption, but we do not have the exogeneity. So the covariance between x and u is simply assumed to be a delta, which could be non-zero, which is unknown. And of course, delta is k-dimensional vector. The first part of the question is, so beta 0 is the true value, and then let's find an observationally equivalent parameter value, right? The idea is, as you know, it's about the exogeneity. So the reason for identification failure is due to the failure of the exogeneity condition. So that is a clue. So like here, the idea is if the covariance is delta, say let's delta 0, that is a true, if delta 0 is the true covariance, then beta will be the corresponding parameter. So that means if you knew the value of delta, then you would be able to identify beta. Now then, how can you, the problem is just you do not know delta. So then, an observationally equivalent parameter will correspond to a different value of delta. Say delta tilde is a different value of delta 0. So suppose delta tilde is different from delta 0. And then I am going to define beta tilde and u tilde that satisfies yi xi transpose beta tilde plus ui tilde. Okay, so I will I have to choose beta tilde and u tilde in this way, and at the same time expectation of xi ui tilde is delta tilde. Okay, how can we do that? I will just modify u tilde. I will define u plus say xi transpose. Let me just write it down. So let's think about this u tilde. So original u is included, plus I add something that starts with x because I'm changing the covariance with x. So because I include x, so it will affect the covariance between x. Okay, then let's calculate. Ui tilde is ui plus xi transpose xi transpose inverse times u tilde minus u like delta tilde and delta 0. And then first let's think about this. If you calculate this, then you have this plus expectation x transpose expectation x transpose inverse times delta tilde minus delta 0. Okay, and then this guy, the first guy, is delta 0, and in the second term this expectation and this expectation cancels out. That's the inverse, so you get this. So that means you are going to get delta tilde as we wanted. And then another reason why I include x transpose here is because this much will be cancelled out from beta tilde. Okay, so let's go to the let's start from the original form. This is the original true parameter. Okay, but as I did, so x, I mean it is xi transpose beta 0, and I will add something, and ui plus xi transpose e xi transpose inverse times delta tilde minus delta 0. This is what I defined as u tilde, right? But to maintain the equation equality, I have to subtract this much from here, okay? Right? So then this part and this part will be cancelled out. So that means in the end we have beta tilde plus u tilde. So observationally x and y are still the same, and this equality satisfies full rank assumption and linearity assumptions. So both assumptions are satisfied, so I cannot tell beta tilde from beta 0, right? From the observations of y and x. Y and x are not affected. Linearity, other assumptions are not affected. That is answer to part A. Part B, suppose that delta is not 0. So exogeneity fails if delta is not 0, but you make a wrong assumption that the exogeneity is true. So derive the misspecification bias. So if you assume exogeneity, then you get this. Transpose inverse, right? You would use this identification result, but the estimand, I said the right hand side is estimand, and this is your parameter. Actually, in the true model, the estimand becomes different from the parameter. So let's do that. The estimand can be written as, using the true assumptions, I will use linearity assumption first. Here, xi transpose beta 0 plus ui. So using assumption 1, and then expand xi transpose inverse, and here expectation xi transpose beta 0 plus expectation xi ui. Okay, now then we know this equals delta. Okay, so if the here you are assuming that exogeneity is true, but actually exogenous assumption holds in your like in your mind, but actually it is not. So then it does not go away, and then you get, so first term becomes beta 0, and then second term becomes this. Okay, so this much is misspecification bias.